All right, team members, let's take a look at your assignment 1, which will be due the Monday that we're coming back from break, right? So not next week, which is break, but the Monday after that at noon. And we'll talk about this in class today as well. So you're basically going to make a Kotlin project in IntelliJ. When you're done, you're going to zip up your project folder using these instructions. I'll demonstrate in class if anybody wants to see it. Save it using the standards of student name, student ID, and upload it to our LMS, our course webpage, right? So that's that. So we're going to be covering the stuff we've done in class this week, creating Kotlin classes with methods and properties, passing objects between classes as parameters on the methods. Now that's a new thing we're going to talk about today, using data collections to manage our books here in our bookstore, and using some good design principles with some UML planning to design meaningful interactions between objects. So you're building the data storage and processing logic for a bookstore system. We're not going to get into any UI stuff. It'll be all like hard-coded data in your classes and then outputting to the console. In our Android class, we'll amp it up with some UIs and some database interactions, but not for right now. The bookstore is going to store books, allow customers to add books to their shopping cart, very similar to your final project for full stack, and shows a summary. We'll hard code our data for right now, not doing any UI or database interactions. All right, so we're going to go through this in class tonight. You can read through it now to see where we're going to be going. We're going to be studying data collections. We haven't done that yet, but not too hard, just basically, well, you're going to see the code in a little while in the class. So you're going to add books to inventory. Right, so you're going to construct a book object. You're going to make an inventory object and say add that object. Remember, towards the end of yesterday's class, we were talking about moving object references around in data collections, like arrays. We're going to have a search function. Now, I don't believe we have yet talked about the concept of optionals. I'll get into them tonight, but basically optionals is a thing Kotlin has to accommodate stuff we're going to need in Android, so we're talking about what the optional does. Right, so a customer can add a book object to their cart, and they can print a summary, just like in the Star Trek project we did yesterday, the code example, where we showed how we can make a report on the starships. Well, we're going to make a report on our cart, and that's what your output might look like. Right, so you're going to be now you don't have to do it exactly this way, right? If you want to get creative and more imaginative in how you factor your responsibilities, right? Think about the core responsibilities you need. Well, they're right there in your use cases. You have to add books to inventory, which means you're going to, in terms of lexical analysis, a lexical analysis of this would tell us we're going to need a book object, and we're going to need a collection object called inventory to store all the books in. And then you're going to have a search function, and you're going to have the ability to add a book to a customer's cart, exactly like you did in the full stack project. And then you're going to print a summary of what's in the cart. So if you want to go with other classes, right, if you want to refactor it in another way, great, go and do it. I'm going to show you one simple way, but there's many ways to solve any type of a programming problem. So we're going to look at how your classes are defined. We're going to just look at your use of collections, how effectively you are passing data between classes using methods. You've implemented all the requirements of your assignment. Right, your output is formatted in an easy to read way. You're making lots of use of comments and making your code readable, meaningful variable names. And function names. And this is like a little option, right? I'm not going to take any marks off if you don't do it, but if you do it, I mean, I can't give you more than 100% in any case anyway, but you know, if you add that, that'll be like an extra little thing you can demonstrate there. So here's a table showing how each class in our bookstore app is going to adhere to the knowledge principle, the GRASP principle. And here's an example of one possible way it might run. Right? There's other ways you can do it, but here would be one way. So we've gone ahead and set ourselves up in IntelliJ. We're going to run this program now. Now, I've chosen to do it here all in one file. You could put it in separate files, which would be kind of a good practice. I'll demonstrate that in class. But everything now is running out of main. And if we run our code, you would get something that looks like this. Anyway, see you in class, and we'll talk about it more.